Alrighty, physics, let's get into some circuits. So, things that we've talked about already. Circuits. Circuits. First off is a closed path where electrons can flow. In order for current to flow, you have to have some potential difference, right? Some voltage. You have to be pushing electrons from one area to another in order to get them to actually go around the circuit. And we talked about this just the slightest bit, but it's like a ski lift where the electrical potential difference can be equated to gravitational potential difference, where as you go up in a ski lift, you're gaining potential energy, and then you're going to have to get down that ski lift or down that slope some way. Hopefully, if there's a lot of resistance, you can take it nice and slow and get down the mountain safely. Or if there's nothing stopping you, you can actually just zoom all the way down and possibly hurt yourself because you're flowing too fast. And that's the equivalent of like an electrical short. The idea of current flowing without anything inhibiting it, anything slowing it down, causing an electrical short. And so what we're going to be talking about today is a whole bunch of different types of circuits, or really just the two main types of circuits, and we're going to be looking at it without using some math, and we're going to do some math kind of next week. So let's talk about the symbols first that we have in our circuit diagrams. And so these are just things that you should be drawing or writing down in your notebook. So a single cell is something that would look like this, where these lines that are perpendicular to the cell, so this is the cell right here, the lines that are perpendicular represent wires. And so one cell would just mean a negative side and a positive side. And so this is like a piece of a battery. And in fact, when we look at a battery, a multiple cell battery, it'll actually look something like this. So this is a 3-cell battery. Yeah. And so we have the negative side of the battery and the positive side of the battery. The cell is just one aspect of this. In fact, we don't really use cell all that much. Battery is where we mostly use it. And I usually just draw 2-cell batteries. But just notice that the battery, the short end is the negative side. The long end is the parallel side. We should be connecting that. And that the wires come out perpendicular to the battery. A switch has a wire that comes in, and it looks a little something like this. So here's the wires. Sometimes you'll see it with little dots here. Very common. And so it's the imagining dropping the wire down to actually connect the circuit. Voltmeter. Physicists aren't all that creative in terms of some of these things. There it is. And so a voltmeter actually just is a circle with, get this, a V in it. Voltmeter. Bam. Now, I bet you can't guess what an ammeter is because physicists are super creative, but you guessed it. Phenomenal stuff. Capital A in it. Ammeter. Voltmeter. Ammeter. A resistor is a little bit cooler. It looks a little something like this. But you missed the sound effects. So a resistor is kind of like these, I don't want to call them squigglies, but they're like zigzags. That's the better name for them. So it's a zigzag back and forth. And that's a resistor. And then a lamp, which is also known as just a light bulb, but fancy term for it is a lamp. The wire comes in. We have a little this, and then you draw a circle around it. So that one's a little bit more creative. It actually looks kind of like a light bulb. So now we're going to get into actually building a circuit. So now there's two types of circuits that we're going to be building. I'm going to start with a series circuit. And we're going to use the program that you probably used last week in your choice of assignment, which is this. So we're going to use just the like the normal view instead of the schematic view. So let's throw in a battery here. And so remember, we need to have a circuit that can flow from the positive to the negative side of the battery. Now notice if I connect these 2 points of the battery, well, I don't have anything that's stopping the flow of these electrons. I have nothing that's stopping the flow of these electrons, which is causing the circuit to short. It's not, you're not slowing down the electrons at all, and so these electrons can flow freely, and that causes there to be a short here. Too much current flowing without anything slowing it down. So what if we throw in a resistor here, or actually, yeah, we'll leave a resistor here. I'll throw in a switch. Bam. We click the circuit. Now we have a flowing circuit, but it is flowing in a manageable sense, where we can actually control the amount of current and not have a short. This is a series circuit. Now that seems really, really simple, and it really is. A series circuit is something that has one pathway for the electrons to go. One pathway for the electrons to go. Now I'm going to reset this, and let's build a little bit better one. So let's rotate this here. And so a series circuit could look something a little bit more like this. Say we have here, we got a switch. Bam. We'll throw a light bulb in here. We'll throw a light bulb in here. Let's move all this down. We'll throw a light bulb in here. And we will connect our circuit. So now, notice, we have electrons that want to be going from the negative side to the positive side, right? They want to get towards that positive. And we have 3 light bulbs in between. I throw my switch connected, and we have 3 light bulbs that are lit up. Look at that. Now there are things that we can do to make the light bulbs a little bit brighter. Well, what happens if we take this 9-volt battery and make it a 35-volt battery? Dum, dum, dum. All of a sudden we have a lot more light, and you'll notice that the electrons are also flowing faster. Now it's not necessarily that they're flowing faster as much as it's more electrons flowing. The speed isn't as greatly affected as it is the amount of electrons that are flowing, and we'll talk about that a little bit more. But just recognize that this is what we call a series circuit. Now, if you wanted to look at the schematic view of it, notice these are things that we've just talked about. I'm going to open up the switch real fast. So the light bulbs are drawn a little bit differently, but look, we have a battery, or at least the cell of a battery. If we zoom in here, we have a switch. We have our lamps. Now they just do it as a little kind of bump and then a circle, but the little bumps in the circle, and wires connecting all of it. You'll notice the resistor, if we throw in a resistor, the resistor still has that zigzag mark to it. And so there's a whole bunch of other different things. They use dollar bills, paper clips, coins as just resistors, because they just flow, or they limit the flow of current. So let's jump back to our PowerPoint, and let's look at this. So a series circuit is one where a circuit has one defined loop. The current can only go one direction, right? In order for the current to get from the positive to the negative, or vice versa, depending on if you're talking about conventional current or not, there's only one pathway. They have to go through all 3 of these resistors. Okay, now we're going to skip a couple slides, and we'll talk about this stuff next week, how the current going through one has to be the current going through all of them, and the resistance is equivalent, and the voltage drops have to be summed. But for right now, we are going to actually talk about another type of circuit. Okay, so that was a series circuit, but my question to you is, can I connect this a different way? And of course the answer is yes. And I'm going to show you how we connect what we call a parallel circuit. So this one pathway series circuit. Now let's make what we call a parallel circuit. So I'm going to start here by adding a battery. Now, what I want to do to this battery is I'm going to set it up where there's going to be multiple pathways. If series is when there's one pathway, parallel is going to be obviously when there's multiple pathways. So now check this out. So say I take a wire here, and a wire here. Okay? So now I have branches of where these electrons can flow. I'm going to add a switch to each one, and I'll talk about that later. Just recognize that it's fine. I'm just going to add a switch. We're going to close all these switches at the start, and let's throw in a light bulb on each of these to see. Whoa. Can space this out a little bit more. Bam. Now, where these all split up, well, they're going to all have to connect. So let's connect these. Bam. And bam. So now we have one pathway here, splitting into 3 pathways, connecting back to one pathway. And let's connect these. So once I let go of the mouse, now we have some current flowing. So now you'll see that we have 3 light bulbs lit up, and they are lit up in what we would call a parallel circuit. Now, a parallel circuit is a circuit that has multiple pathways to it. Now, if you're an electron who wants to go around this circuit, you're going to flow through here, and then at this point right here, you have to make a decision. Do I want to go through, say, light bulb A, light bulb B, or light bulb C? Now, I asked you at the start of this week, how is it possible that one light bulb can go out and still have a connected circuit? Well, the reasoning is because you have a parallel circuit. Now notice, what is going to happen when I turn off the switch right here? I'm going to disconnect this switch. Now I want you to think to yourself, are these 2 light bulbs going to go out? Now if I turn this off, you'll notice that this light bulb does go out, but these 2 do not, which makes sense because look at the electrons. The electrons want to get from the negative to the positive. We still have 2 pathways that allow that to happen, but we don't have one here. And so the electrons are going to see this point. They're going to go, oh, well, there's no connection here. There's nothing that's driving me through this part of the circuit, but there's something that's driving me through these 2 parts, and so you can do that. In fact, we can disconnect a second one, and now we have, this is actually just a series circuit once there's only one connected because there's only one pathway. But we can connect multiple, and you'll see that. Now, I want you to also recognize here, now this is something that's big that we'll talk about in the math. Notice the speed of the electrons as we are flowing. Now, if we have electrons that are supplying 3 light bulbs worth of batteries, that means that there are more electrons flowing through these parts of the circuit where there's all 3 of the currents kind of added up. And as we disconnect parts of the circuit, they actually start slowing down. This is where it can get really dangerous. The more light bulbs you add in parallel, the actual more dangerous the circuit gets because you're forcing this battery to supply more electrons and to push these electrons faster through the parts where there's all the currents going through it, which means that you are more likely to short your circuit. So it's actually kind of interesting. The more light bulbs you add to a circuit that is in parallel, the more likely you are to short that circuit. And so it'll look something like this. So a parallel circuit is one that contains more than one loop where current can go through. So once again, we have current flowing through. It hits this point right here and it goes up. Which way do I want to go? I can either go through resistor 1 or I can go through resistor 2. And then right here, they connect back. So notice that the current that's flowing through, all of the current is flowing through this blue portion right here, and all of the current is flowing through this blue portion right here. But a piece of that current, not the entire thing, is flowing through resistor 1, and not the entire thing is flowing through resistor 2. It gets chopped up. Okay? And we'll talk about that next week in the math of it. But for right now, as long as you recognize the difference between parallel and series circuits, and we're going to be building some on our own through this same site, that is where we're going to pause for this week, and I will see you next week. All right, see you later. Bye.